Part 1.
You will hear a conversation between Harry and Andrea, two students who have just finished their final exams. First, you have some time to look at questions 1 to 5. Listen carefully to the conversation and answer questions 1 to 5.
Hi Andrea, how are you feeling now that exams are over?
It's fantastic to have finished, isn't it? And to sleep in every morning. What about you?
Well, I've been catching up on sleep too, but I've got a lot to do before I leave for England. Perhaps you could give me some advice. I've got a lot of things I can't possibly take back with me, but I don't know what to do with them.
Well, it depends on what sort of things they are and whether you're thinking of giving them away or selling them.
Well, almost everything. Furniture, the fridge and other kitchen stuff that I bought from the previous tenant. But the new people have already got what they need, so they're not interested in buying stuff from me. I can't afford to give it away, but I'm not sure how to sell it all. Oh, and there are some clothes and books as well.
Why can't you take them?
The books are really heavy. It's so expensive if you exceed the airline baggage allowance. And the clothes just won't all fit in my suitcase. It's amazing how much stuff I've accumulated since I've been here. Anyway, I don't think I'll need as many summer clothes in England as I have here in Australia.
I see. Well, there are several alternatives. First of all, you could put up notices around the university about the books. You know, on the notice boards in the Student Union building and in the economics department. Anywhere second and third year students will see them. People are always keen to buy cheap textbooks.
OK, what should I say on the notices?
Just put the titles, authors and price you want, your name of course, and maybe put your phone number on those little tear-off tags.
That's a good idea. And what about the furniture?
You could try doing the same thing, but usually students are away all summer, so they don't want to buy furniture now. Another place to try might be a second-hand shop. Someone from the shop will usually come around and give you a free quote, and then you can decide. But you don't usually get much money for that sort of stuff.
Before you hear the rest of the conversation, you have some time to look at questions 6 to 10.
Another alternative is to put an advertisement in the Trading Post. Do you know that paper? It comes out every week advertising things people want to sell. You have to pay to put the advert in and then hope people phone. Give them as much information as possible, and if they're interested, invite them to come and have a look. The hard part is agreeing on a price.
No, I haven't seen the Trading Post. But I should have a look at it, and I could advertise the fridge, the microwave and the furniture. But the kitchen stuff isn't really that good. You know, old cutlery, a few pots and pans and some plates and things. What shall I do with them?
Well, another option is to donate the kitchen things to a charity shop. You know, like the Salvation Army or St. Vincent de Paul. Why don't you get a second-hand shop to give you a quote first?
Yes, I could do that. Find out how much they'll give me and then decide whether to sell them or give them away. But I've still got the clothes.
A charity shop will take them too, as long as they're in good condition. And even though you don't get any money, at least you know that someone who really deserves some help has benefited.
That's a good point. I'll advertise the expensive stuff, the furniture, and donate the clothes and kitchen stuff. Let's go and buy a trading post and you can help me write the advert.
Well, actually, I'm interested in buying the fridge and the microwave, depending on the price, of course.
OK, let's see how good you are at bargaining.
That is the end of part 1.
You now have half a minute to check your answers.
Now turns to part 2.
Part 2.
You will hear a trainee teacher called Eve talking to her university tutor about her preparations for teaching practice.
First, you have some time to look at questions 11 to 15. Now, listen carefully and answer questions 11 to 15.
Hello, Eve. Come in and sit down. How's it going?
Fine, thanks. I'm looking forward to my teaching practice next week.
Good. Now, you've got 2 classes, haven't you? Year 3 and Year 6. Have you done your lesson plans?
Well, I've decided to take the topic of renewable energy. I haven't done a lesson plan for Year 6 yet, but I thought I'd base their lesson on an example of very simple technology. So, I've brought this diagram to show you. I got it from the internet.
Let's see. A biogas plant. So this is equipment for producing fuel from organic waste?
Yes. The smaller container on the left is where you put the waste you've collected.
Right, and from there it's piped into the larger tank.
That's right. And that's slurry on the base of the larger tank.
Right. And what exactly is slurry?
It's a mixture of organic waste and water.
So is that pipe at the bottom where the water comes in?
Yes, it is. As the slurry mixture digests, it produces gas, and that rises to the top of the dome. Then, when it's needed, it can be piped off for use as fuel in homes or factories. It's very simple.
I suppose there's some kind of safety valve to prevent pressure build-up?
That's the overflow tank. That container on the right. As the slurry expands, some of it flows into that, and then once some of the gas has been piped off, the slurry level goes down again, and the overflow tank empties again.
I see. Well, I think that's suitably simple for the age level it's for. I look forward to seeing the whole lesson plan.
Thanks. And can I show you my ideas for the Year 3 lesson?
Of course. Let's...
Before you hear the rest of the talk, you have some time to look at questions 16 to 20. Now listen and answer questions 16 to 20.
I thought I'd introduce the topic by writing the word energy on the board and reinforcing the spelling and the pronunciation. Then I'll do a little mime, run on the spot or something, to convey the sense.
I'd keep it brief at this stage.
Yes, I will. Then I'll wipe the word off and write the question, where does energy come from, and see what the pupils come up with.
Fine. I'd suggest that you just brainstorm at this stage and don't reject any of their suggestions.
Yes, that's what I was going to do. Then I've produced a set of simple statements like energy makes cars move along the road and energy makes our bodies grow. There are 8 altogether.
Are you going to give them out as a handout or write them up on the board?
First, put them up on the board and then I'll read them out loud. And I'll get the pupils to copy them out in their notebooks. I'll also ask them to think up one more similar statement by themselves and add it to the list.
Good idea.
After that, I thought I'd vary things a bit by sticking some pictures up of things like the sun and plants and food and petrol and a running child. And I'll get the pupils to work out what order the pictures should come in terms of the energy chain.
I think that's a very good idea. You could move the pictures around as the pupils give you directions.
Yes, I think they'd enjoy that. And to finish off, I've made a gap fill exercise to give out. They'll be doing that individually, and while they're writing, I'll walk round and check their work.
Good. And have you worked out the timing of all that? It'll probably take you right through to the end of the lesson.
That is the end of part 2.
You now have half a minute to check your answers.
Now turns to part 3.
Part 3. First, you have some time to look at questions 21 to 26. Now listen carefully and answer questions 21 to 26.
Good evening, and welcome to this month's Observatory Club lecture. I'm Donald Mackey, and I'm here to talk to you about the solar eclipse in history. 1,000 years ago, a total eclipse of the sun was a terrifying religious experience. But these days, an eclipse is more likely to be viewed as a tourist attraction than as a scientific or spiritual event. People will travel literally miles to be in the right place at the right time to get the best view of their eclipse. Well, what exactly causes a solar eclipse? When the world goes dark for a few minutes in the middle of the day. Scientifically speaking, the dark spot itself is easy to explain. It is the shadow of the moon streaking across the earth. This happens every year or two, each time along a different and, to all intents and purposes, a seemingly random piece of the globe. In the past, people often interpreted an eclipse as a danger signal heralding disaster, and in fact, the Chinese were so disturbed by these events that they included among their gods one whose job was to prevent eclipses. But whether or not you are superstitious or take a purely scientific view, our earthly eclipses are special in 3 ways. Firstly, there can be no doubt that they are very beautiful. It's as if a deep blue curtain had fallen over the daytime sky as the sun becomes a black void surrounded by the glow of its outer atmosphere. But beyond this, total eclipses possess a second, more compelling beauty in the eyes of us scientists, for they offer a unique opportunity for research. Only during an eclipse can we study the corona and other dim things that are normally lost in the sun's glare. And thirdly, They are rare. Even though an eclipse of the sun occurs somewhere on Earth every year or two, if you sit in your garden and wait, it will take 375 years on average for one to come to you. If the moon were any larger, eclipses would become a monthly bore. If it were smaller, they simply would not be possible. The ancient Babylonian priests, who spent a fair bit of time staring at the sky, had already noted that there was an 18-year pattern in their recurrence, but they didn't have the mathematics to predict an eclipse accurately.
Before you hear the rest of the talk, you have some time to look at questions 27 to 30. Now listen and answer questions 27 to 30.
It was Edmund Halley, the English astronomer, who knew his maths well enough to predict the return of the comet, which incidentally bears his name, and in 1715 he became the first person to make an accurate eclipse prediction. This brought eclipses firmly into the scientific domain, and they have since allowed a number of important scientific discoveries to be made. For instance, in the eclipse of 1868, two scientists, Janssen and Lockyer, were observing the sun's atmosphere, and it was these observations that ultimately led to the discovery of a new element. They named the element helium after the Greek god of the sun. This was a major find because helium turned out to be the most common element in the universe after hydrogen. Another great triumph involved mercury. I'll just put that up on the board for you now. See, there's Mercury, the planet closest to the sun. Then there's Venus, Earth, etc. For centuries, scientists had been unable to understand why Mercury appeared to rotate faster than it should. Some astronomers suggested that there might be an undiscovered planet causing this unusual orbit, and even gave it the name Vulcan. During the eclipse of 1878, an American astronomer, James Watson, thought he had spotted this so-called lost planet. But alas for him, he was later obliged to admit that he had been wrong about Vulcan and withdrew his claim. Then Albert Einstein came on the scene. Einstein suggested that rather than being wrong about the number of planets, astronomers were actually wrong about gravity. Einstein's theory of relativity, for which he is so famous, disagreed with Newton's law of gravity in just the right way to explain Mercury's odd orbit. He also realized that a definitive test would be possible during the total eclipse of 1919, and this is indeed when his theory was finally proved correct. So there you have several examples of how eclipses have helped to increase our understanding of the universe. And now let's move on the social.
That is the end of part 3.
You now have half a minute to check your answers.
Now turns to part 4.
Part 4.
You are going to hear a lecture on ecology. First, you have some time to look at questions 31 to 35. Now listen to the tape and answer the questions.
Good afternoon. I'd like to turn it over to Dr. Carey, who will talk about the programme in restoration ecology.
Thanks, Chris. A lot of people think that human beings can do whatever they want to the environment. But as Aldo Leopold taught, land is a system of interdependent parts which should be regarded as a community and not a commodity. Well, that idea has influenced what we teach here in our program, where students come from all over the world to learn about restoring native plant communities back into an ecologically natural state. This field is therefore a combination of formal science with practical applications, and that is quite attractive to many people. We have students, for example, from many different nations who come just to take part in this unique program. Our location is also quite unique. We have the world's oldest restored native plant community in Curtis Prairie at the Wisconsin Arboretum. Some say that this is proof that the science of restoration ecology was birthed in Wisconsin. Well, that may be oversimplified, but our reputation is strong. But students don't have to study prairies only. One student, Edmund Mukala from the Congo, came to study restoring ancient wetlands in the Congo using knowledge gained from historic samples of the soil seed bank. Not all the seeds survived, but some can remain dormant for many years. Mr. Mukala wanted to find out what type of community would be most similar to that ancient seed bank. He has recently returned to the Congo and is now cooperating with the government to implement his findings.
Now look at questions 36 to 40. As the talk continues, answer questions 36 to 40.
So the only prerequisite for doing research here is that it is a native plant community. That means not just prairies, but wetlands, woodlands, savannas, and other environments. We're proud of the diversity of research topics in our program. And we continue to grow. This year we have 32 new students from 8 different countries. When students first arrive, they begin rigid coursework in statistics, ecology, plant identification, and the theory of landscape change. Then they take part in internships at local conservation agencies such as the Arboretum, the Nature Conservancy, the Parks Department, and others. We find internships to be crucial in helping students apply the knowledge they have gained in the classroom. And we're proud to say that, since the beginning, we have graduated 277 students with master degrees from our programs and 122 students with PhDs. Some have gone on to bigger and better things. One graduate is now the director of the Worldwide Fund for Nature in China. Another is the director of Parks Development in California. And others now lead their own research departments in universities around the world.
That is the end of part 4.